Okay, so we are now in the third law of motion. So by this time, you should be able to have a good grasp of the first law, which is a more qualitative description of motion. Gives us the idea that objects have a tendency to resist change, and that change is referred to as inertia. And you were able to measure indirectly the inertia of an object by uh, conducting a lab, which is related to the mass. And also, you should be able to look into that. Um, the first law only applies to objects that are being taken into account by an observer that is in its inertial frame of reference. So if the observer is a non-inertial frame of reference, then it is not valid on his end. Also, you should able to look into the second law, a more quantitative aspect on how forces, mass affect acceleration, and you should able to look into the mathematical equations for that. So this is more a quantitative aspect of the second law. But the big question is, okay, we know that force acts on objects and that cause the objects to accelerate. But where do forces come from? That was a big question according to Isaac Newton. And he was able to figure that out. And he referred to it as that it does not only exist in one object. So objects that are interacting should have the forces in them, which are of equal magnitude. So if you look at this picture in here, so you are driving a nail into a block with a hammer, and with that, you are able to accelerate the nail and drive it into the block. And the hammer must exert a net force on the nail. So part of Isaac Newton's genius idea was that he was able to recognize that force is not an isolated thing. So it does not exist. Force in nature always exists in pairs, and that is the third law. So it also referred to as the law of action and reaction, and that is for the two objects you are looking into. According to him, as the nail is driven into the block by the force exerted by the hammer is slowed down and stopped by the force exerted by the nail. So, how does it happen? It seems to be counterintuitive in terms of, it seems to be contradicting in terms of two objects exerting a force with the same magnitude, and the other one is accelerating. Come to think about this, which one have more mass? Well, definitely the hammer. So if you go back to the second law, and if you're looking into the equation for acceleration, which is the sum of the forces acting on the object over the mass. So if you're looking at the hammer, who is more massive than the nail, given that the applied force is the same, therefore we would accelerate faster. The hammer or the nail? So looking at the relationship between acceleration and mass, which is inverse, so the smaller mass, the greater the acceleration. Therefore, the nail is the one that's going to accelerate. So that is pretty much the concept between the third law. Again, this is pretty important. This law tells us that you cannot, and you better not add to find the sum of the forces exerting on one object, because action force, reaction force are acting at different object. So always think about that. So let's take a look at this another picture in here. So we have two objects. So the action force is equal to the reaction force, and only in opposite direction. So he was able to describe this in that sense that there is no isolated force that exists. And think about an object, the falling apple concept, the story behind why he was able to develop this, because a falling apple fell on his head. But think about this: the gravitational force of attraction against the apple by the earth is that of equal magnitude to which the apple exerts a gravitational force of attraction against the earth. But why is it that the apple falls towards the earth? Why did it fall towards the earth? Now come to think again, just like the nail and the hammer. Which one have bigger mass? Well, definitely the earth is way, way more massive than the apple. Therefore, who is going to accelerate? Way faster if you're going to look at that. Therefore, the less massive object that are interacting will accelerate. So technically, the apple is going to be the one that is going to accelerate towards the earth. That's what we will see in terms of these two objects interacting. So that's pretty much how it is explained in terms of the third law. So it's just like you're walking. So you exert a frictional force against the ground. The reaction force of the ground against our foot propels us forward. In the same way, the tires on a bicycle exerts a frictional force against the ground, and the reaction on the ground pushes the bicycle forward. That's pretty much sums up our third law. So if you look at this, you have a computer monitor that is sitting on a table. So the Earth exerts a gravitational force on the monitor, and so as the monitor exerts a force, and which caused this not to accelerate downward because it is held up by the table, which is an upward force called the normal force. And normal force, but technically the term for perpendicular force in a math context, in a physics context. So if you look at the context in terms of science, normal force is an elastic force that comes from cohesion of the particles and is in electromagnetic in origin. So it balances the gravitational force acting on the monitor, preventing the monitor from falling through the table, and can have any value whatever you wanted to in terms of not breaking the table up to a point where it might break. So in that case, you could see that the magnitude of the forces are action and reaction as always come in pairs, because the monitor is not accelerating in any direction. Second law gives us a relationship that these are of equal magnitude. So that's another thing in terms of third law. Again, do not, and you cannot add and find the sum of the forces exerting on only one object, and it should never show up in your free body diagram. So the action and reaction force should never show up in your free body diagram, because in your free body diagram you are isolating an object that you are studying out from the entire system that includes the external environment. So if you're going to look at action and reaction force, you think that, okay, where does the force exist? Why does it exist? It's because of the action and reaction, and that's it. That's pretty much it. Okay, so that's pretty much sums up third law.